Picture this. You're an astronaut, the first human to set foot on a planet beyond our solar system. Your boots sink slightly into the crimson sand, a texture unlike anything you've felt before. You look up at a sky painted with hues of lavender and gold, two suns casting an ethereal glow on the landscape, a sight that defies earthly sunsets. The air is thick, heavy with the scent of unfamiliar flora, each plant a mystery waiting to be unraveled. This, my friends, is a super-Earth, a world that challenges our understanding of planetary science. This isn't a scene from science fiction, though it certainly sounds like it. It's a tantalizing glimpse into our potential future. Super-Earths are very real, and they're captivating the minds of astronomers and space enthusiasts alike, sparking dreams of interstellar exploration. These planets, larger and more massive than Earth, represent a new class of worlds that we're just beginning to understand, each with its own unique characteristics. But what makes them so special? Is it their size, their potential for life, or something else entirely? Could one of these alien giants be our next home amongst the stars? Could we adapt to their environments and thrive? Let's dig in and explore the fascinating world of super-Earths, where the possibilities are as vast as the cosmos itself. Buckle up, cosmic explorers, because things are about to get super interesting. The journey to understanding these worlds starts now. So, what exactly are we talking about when we say super-Earth? Simply put, these are planets that are more massive than Earth, but lighter than gas giants like Neptune. Think of them as Earth's bigger, brawnier cousins, with some packing up to 10 times our planet's mass. But here's where things get really fascinating. Super-Earths are a diverse bunch with unique characteristics. Some are rocky worlds like ours, with solid surfaces and the potential for liquid water, making them prime candidates for life. Others are enveloped in thick atmospheres, leading to extreme weather conditions, scorching hot or frigidly cold. Some even orbit incredibly close to their stars, completing a year in just a few Earth days, which could affect their climates dramatically. This incredible diversity is what makes super-Earths so exciting for scientists. They offer a glimpse into planetary evolution unlike anything we've seen in our own solar system. By studying these strange new worlds, we can learn more about how planets form, what makes them habitable, and whether we're truly alone in the vastness of space. Some super-Earths might even have extreme volcanic activity, with lava flows and eruptions that dwarf anything on Earth. Others could possess unusual magnetic fields, creating auroras and other phenomena that are both beautiful and bizarre. And let's not forget the possibility of rings and multiple moons, adding to their otherworldly allure. Some super-Earths may have unique geological features, such as towering mountains and deep valleys, sculpted by forces we can only imagine. The potential for life on these planets is one of the most intriguing aspects, as some may harbor conditions suitable for microbial life or even more complex organisms. As we continue to explore these fascinating worlds, each discovery brings us closer to understanding the vast possibilities that lie beyond our own planet. Here's a mind-blowing fact: super-Earths might be the most common type of planet in our galaxy. That's right, these massive worlds could outnumber even the familiar gas giants and icy planets we learned about in school. Astronomers are practically giddy with excitement over this discovery. It means that our corner of the cosmos is teeming with potential targets for study. Every super-Earth we find is a golden opportunity to unravel the mysteries of planet formation, atmospheric composition, and even the tantalizing potential for life beyond Earth. The sheer number of super-Earths also dramatically increases the odds of finding one in the habitable zone, that sweet spot around a star where temperatures are just right for liquid water to exist on a planet's surface. And where there's water, as we know it, there's a thrilling chance for life as we know it. So, how do these supersized planets form? It all begins in a protoplanetary disk, a massive cloud of gas and dust around a newborn star. These disks are the birthplaces of planets, just like in our own solar system. Tiny dust grains stick together, forming larger and larger clumps. Over millions of years, these clumps grow into planets. Their size and composition depend on their location in the disk and the materials available. Super-Earths likely form in the outer regions of these disks, where there's more material. They may start as rocky cores, like Earth, but then quickly gather massive atmospheres of hydrogen and helium. Some may form from the merger of multiple smaller planets, creating huge worlds. The temperature in the disk is crucial. In the hotter inner regions, rocky planets form, while in the cooler outer regions, gas giants and super-Earths can develop. Gravitational forces can move these planets within the disk, changing their distance from the star and affecting their final size and composition. Examples of super-Earths include Kepler-186f, a planet slightly larger than Earth orbiting a red dwarf star, and Gliese 607cc, a planet with a mass almost 4 times that of Earth, located just 22 light-years away. The habitability puzzle of super-Earths. Now for the million-dollar question. Could a super-Earth be habitable? Could life as we know it, or perhaps even stranger forms of life, thrive on these alien worlds? The answer, like most things in astronomy, is a resounding maybe. Here's the thing about habitability. It's a complex equation with many variables. Size and mass are just the tip of the iceberg. A super-Earth's atmosphere, the type of star it orbits, and even its distance from that star all play a crucial role in determining whether it could support life. Some super-Earths might be scorching hot, with crushing atmospheric pressure that would make Venus seem like a vacation spot. Others could be frigid, airless wastelands. But some, just maybe, might be that perfect blend of conditions, a cosmic Goldilocks zone where liquid water flows freely, and life, in all its weird and wonderful forms, has a chance to take root. If super-Earths are so common, why haven't we found more of them? Imagine trying to spot a firefly next to a spotlight from miles away. That's the challenge astronomers face when searching for these distant worlds. Super-Earths are relatively small and faint compared to their host stars, making them incredibly difficult to detect. Most of the super-Earths discovered so far have been found using the transit method, where astronomers look for tiny dips in a star's brightness caused by a planet passing in front of it. But this method requires a bit of cosmic alignment. The planet's orbit has to be perfectly aligned with our line of sight from Earth. Otherwise, we're out of luck. And even when we do detect a transit, it takes multiple passes to confirm the planet's existence and determine its characteristics. Finding a habitable super-Earth is even more challenging. It has to be in the star's habitable zone, where conditions are just right for liquid water. This narrows down our search even further, making the hunt for a new home a true cosmic needle in a haystack. Despite the challenges, the future of super-Earth research is incredibly promising. New telescopes and groundbreaking technologies are being developed that will revolutionize our ability to discover and explore these fascinating planets. Space-based telescopes like the James Webb Space Telescope, launched just a few years ago, will enable us to study the atmospheres of super-Earths in unprecedented detail, sparking new hope for finding life beyond our planet. By analyzing the light that passes through these atmospheres, we can identify the gases present and search for telltale signs of life, such as oxygen, methane, and water vapor. Ground-based telescopes are also joining this exciting quest. Giant observatories with advanced adaptive optics systems can compensate for the blurring effects of Earth's atmosphere, allowing us to image distant planets with incredible clarity and precision. These telescopes will be essential for characterizing the atmospheres and surfaces of super-Earths, fueling our curiosity and driving our search for signs of life in the cosmos. The secrets of distant worlds are waiting to be unlocked, and with each discovery, we come closer to understanding our place in the universe. The ultimate question in the realm of super-Earths. The discovery of super-Earths has reignited one of humanity's oldest and most profound questions. Are we alone in the universe? With billions of these potentially habitable worlds scattered throughout our galaxy, the odds of life existing elsewhere suddenly seem a lot less far-fetched. Every new super-Earth we find, every atmospheric signature we analyze, brings us one step closer to answering this fundamental question. But the search for life beyond Earth is about more than just finding aliens. It's about understanding our place in the cosmos, our unraveling the mysteries of life's origins, and pushing the boundaries of human knowledge and exploration. So, the next time you look up at the night sky, remember this? Out there, among the billions and billions of stars, super-Earths are waiting to be discovered. And who knows what incredible secrets, what wonders of life might be hidden on those distant worlds. The cosmos, my friends, is full of surprises. And perhaps, in seeking these answers, we might just find a deeper understanding of ourselves